Digital feedback loop, or DFL, we call it for short, is our way of providing our developers and our customers' developers the access to see how their software and their hardware is performing in the field.
The digital feedback loop is crucial if you really want to keep improving and delivering more and more value to your end customer.
Imagine that you had the ability to understand exactly what the end user likes or dislikes, what he is satisfied with, what he is dissatisfied with. Digital feedback loop is actually the missing link that provides you the pipeline to ensure that data is possible to send back to the developer so that you get immediate feedback from the field.
There's two different algorithms that run. One of them is on the car, and this allows moment-to-moment, real-time driving behavior. There's also the algorithm that runs in the cloud. This one watches the vehicle over longer terms and understands the trends of that vehicle.
A digital twin is, in a sense, the virtual manifestation of the actual device. You create a digital twin that acts just like the device, but it's virtual. Now you feed all the data into it. Now you see how the entire system works. So now you can really see how everything comes together. You understand the correlation between things. Then you close the loop by generating a new code, using over-the-air upgrades, push it back to the car, and then the loop continues.
We all know it's easier to address software problems early. It gets much more expensive, much more difficult later in the process. So we can go in and we can see CPU performance, we can see memory performance, we can pull usability data, we can see timing data, and we can see the trends. We can address those problems early.
This kind of technology shortens the development cycle and allows continual updates. It's important in systems engineering to have access to data. Take data from the field, play it back through our hardware, play it back through our software, and really know what was the vehicle seeing at the time, and really understand what it was doing and why it was doing that. Having more cars in the field and actually being able to get information from those is better.
Sometimes the data on a singular dimension doesn't tell you a whole lot. But when you collect all the feeds and you put it into the system, the data will tell you stuff that you didn't even think about. You upload the data from the device on multiple devices, you push it to the cloud. You see the interaction between the different sensors and data and so on, then the issues or problems or improvement manifest themselves.
Anything learned on one vehicle can be taught to all the other vehicles.
This is a pipeline that Wind River and Aptiv are building together. This has to be an end-to-end tool chain because if you think about the develop, deploy, and operate cycle of development, we're talking about operate here. And operation requires continuous, reliable connection to the vehicle. Wind River, coming in from the telecommunication world and having a very strong presence there, brings that automatic mindset that the developer needs that information, and hence DFL as a tool is embedded in their portfolio. This is something that we can leverage already now.